Last time we started on chapter 6. I'm going to start from where I left off. That was factors affecting solubility of solute in a solvent. Let me share my chapter 5 slides. All right. Can you see my chapter 6 slides on slide page on solution and colloids?
Yes.
All right. I'm glad you can see it. Let me move things around.
Certainly not. And NAACP President Derek Johnson. President Johnson, it's great to see you. Thank you.
Okay, somebody's mic was on. Please turn off if you are not talking to me or not. When you need to talk, then you can turn it on. Okay, let me go through this. We started on chapter 6. We talked about homogeneous mixtures. Topic of the chapter 6 is homogeneous mixtures. Mixtures of elements, two different elements, two different compounds, or combinations of elements and compounds. Most common type of homogeneous mixtures, which we call solution, are based on physical states of the solute and the solvent that you are mixing up. We talked about it. Gas plus a gas give a gaseous mixture. Liquid gas in a liquid give a liquid gaseous mixture. So we go now 6 types of homogeneous mixtures. Last one was solid alloys, when you mix up metals, two metals. There are some distinguishing characteristics of a homogeneous mixture. For example, if you think about a solution, it's a truly homogeneous mixture because true solutions are normal solutions that we find in nature. Colloids are solutions that are opaque, like milk solution, liquid milk. That's not a true solution because it's not transparent. It's opaque. So we talk about different characteristics, various characteristics of homogeneous mixtures. Now we are about to start factors affecting solubility. All right, that's where we left off. I am going to go to the slide where I can start the one of the factors that affect the solubility of a solute in a solvent when you make a homogeneous mixture is pressure. Pressure don't have effect on solubility of effect. Solubility doesn't affect the solubility of liquid and solid solutes in a solvent, because liquids and solids are not affected by pressure. They are not compressible. Therefore, pressure don't have effect on solubility of solid and liquid in. That's what I'm saying. Pressure has little effect on the solubility of liquid, and the solubility gas, on the other hand, has a large effect from pressure. For example, carbonated water, where we drink a lot of soda, you find carbonated water, different types of. The solubility of carbon dioxide depends on the pressure. In fact, how you put carbon dioxide in carbonated water is applying pressure on the surface of the liquid with the high pressure of carbon dioxide. Then you can get the drink carbonated. Carbonated means carbon dioxide dissolved in water. Solubility depends on several factors. Two components are alike. This is factors affecting how the solute and solute interact. For example, we use the word like dissolves, like similar compounds, solutes and solvents are compounds. They have similar intermolecular structure. That means they have similar polarities. They dissolve in each other. Polar compounds dissolve in polar compounds. We talked about in a previous slide about like dissolves like. Out of these, benzene, carbon tetrachloride are similar. They are non-polar, therefore they mix up. Sodium chloride and water has sodium has charge ions, cations and ion. Water has dipole. Ion dipole is a interaction. Like there are similarities in ionic compound and water. Sugar in water also goes into solution because sugar is C12H22O11, which has so many OH groups. Sucrose has so many OH groups. Therefore, hydrogen bonding between hydrogen, water, and sucrose, which is sugar, can take place. Though structurally we can use the like dissolves like idea to describe why two compounds are soluble in each other. We talked about pressure in the previous slide. Pressure has only effect on gas solubility in liquids. Temperature affects both solid, liquid, and gases. Normally, solids and liquid increase temperature means increase solubility. But there are a few exceptions. Some compounds go into solution when the temperature is lower. That's kind of a different issue. Most of them are increasing. Solubility of gases in liquid always increase, always decrease with the increase in temperature. Therefore, to keep, excuse me, gases in liquids like carbonated water, you have to keep it in the refrigerator once the can is open. Let's look at some problems about factors affecting solubility. A beak of salt water contains some solid salt at the bottom. Which type of a solution is in the beaker? If a solid salt is at the bottom, that means it's kind of saturated. Why is saturated? Because the solute has gone into the liquid to the maximum amount. Once you have leftover, that means it's saturated solution at a particular temperature. What type of a solution is in the beaker? It's a saturated. A is the correct answer. A student is preparing sugar water solution to make rock candy. When the student continues to add sugar to the solution, sugar dissolves. What kind of a solution the student has during this preparation? Sugar keeps dissolving. That means mostly pointing to unsaturated. Student prepare a super. Super means when you heat it up, it contains more than it can hold. That's called supersaturated. Student is preparing an unsaturated solution. C is the correct answer. The student is preparing rock candy. When students, no additional sugar dissolves. That's the same question. No additional means that's saturated. This is that means it's left over. Some sugar is left over. That's saturated. What is the solubility of a table salt? That's salt at water 30 degrees. You have to look into diagrams. And 30 degrees is about 36. How do I know? I'm going to show how you look at a graph and look at that one. Sugar solubility of salt solubility of water at 30 degrees. I'm going to show a chart in the next slide. To which of the following solvent-solute combination does the term miscible apply? Miscible means soluble. Miscible is mainly liquid. B. Miscible is a term that we use for dissolving liquid in a liquid. Normally, solid dissolve, gases dissolve, liquid get miscible. Okay, this is a, how do you, I get 30? Around 30 degrees. That's where I got 35 in the last. You draw at 30 here, 25 somewhere here. It's about 30 degrees. Temperature axis is here. You have to look at the temperature and solubility. A is sodium chloride. That's highly soluble. B is less soluble than A. Temperature has less effect. This is the one example that temperature decrease as the temperature increase, solubility decrease. So we normally look at solubility versus temperature diagrams. Now the question here is, at 75, what is the solubility of A? 75 is here. It's about 55 in the middle of. The answer to that question is here is 55. You look at this graph, you can tell where the 4A, that's the graph. It doesn't give everything. This is somewhere here between 55 and 60, 75, 55 and 60 is 55. That's how you got the answer. Which of the following, let me get it down. Regarding the solubility of liquid and solution, solid dissolution, is true. Solubility always decrease as the temperature increases. That's solubility always increase. Solubility decreases as the temperature increases. Solubility usually increases. It's not always. It's usually increase. We chose few examples of solubility decreasing with temperature. Therefore, answer is D. Which of the following is true regarding the solubility of a gas in liquid? Solubility decreases as temperature increase. That's true statement. Solubility increase as the temperature increase. No. Solubility is unaffected by changes in temperature. That's not true. Answer is A, solubility increase. Solubility decrease at the temperature. That's about the gas solubility in liquids. To which of the following does the thermal pollution generally refers? Thermal pollution is taking place where the factories dump their processed water, which is hot water, into a river. That's when the thermal pollution occurs in a lake. Hot water is added to the lake or stream. What effect when you put hot water into a pot? It decreases the oxygen content of warm water as compared with the cold water. It's, in a way, it's true because hot water decreases the solubility of oxygen. Increase the oxygen content, that's not true. Both decrease the oxygen content of water compared to cold water, and the increase the oxygen content of cold water as compared to decrease. That's kind of a complex sentence. Both decrease. A is the for sure answer. That's the correct answer. Let's look at pressure, effect of pressure on solubility. Some sample question. I'm going to see this. Which statement is true of the solubility of a gas in a liquid? Solubility of a gas in a liquid always decrease as pressure. Solubility of gas increase when the pressure increases. That's not true statement. Solubility of gas in the liquid always increase as the pressure increase. That's true. The solubility of gas in the liquid usually decrease as the pressure increases. That's the same as A. That's not true. The solubility of the gas in the liquid usually increases as the pressure increases. That A is the correct answer, always increase. Solubility of gas in the liquid always decreases. That's not true. That A is not correct. B is the correct answer. Solubility of gas in the liquid always increases as the. Which of the following is true regarding the solubility of liquid in a solid? Pressure has virtually no effect on solubility of liquid or solid in a liquid. Solubility of, this is not the answer. Solubility always decreases as the pressure decreases. The pressure don't have effect on solubility of liquid and solid. Solubility also increase as the pressure decrease. That's pressure don't have any effect on solubility. Solubility will decrease That's correct. Pressure virtually has no effect on solubility. That's how you got A. Which of the following law describe the relationship between pressure and the solubility of a gas in a liquid? These are general gas laws. Only law here is that new law that shows the effect of gases in liquid is called Henry's law. Henry's law is pressure of the solution is directly proportional to solubility. As the partial pressure of the gas on the top of the solution increase, solubility increase. That's the Henry's law. D is the correct answer. Henry's law is a solubility directly proportional to the partial pressure of the. That's what I said. That's true. Now you know Henry's law. Partial pressure of a gas above the solution is directly proportional to the amount of gas soluble in the liquid. Which of the following gases are associated with the bends? Bend is a phenomenon that takes place when divers go underwater for a long period of time and come out of the water quickly. They get paralyzed because of the nitrogen gas get more soluble in water under pressure. Normally, nitrogen has highest rate of solubility compared to helium. Oxygen is okay. Oxygen we need solubility. The nitrogen has a pressure temperature curve. That's the solubility. That's the pressure. Higher slope. Therefore, more nitrogen get dissolved in blood under high pressures. When you come out of the water quickly, they get released into the bloodstream. They get nitrogen bubbles get accumulated in the spinal cord around nerve ending. Therefore, it causes the paralysis. So, which of the following gases is associated with Benz nitrogen? All right. Normally, we don't use a high pressure tank of ordinary air in diving. We take a tank with helium and oxygen. Therefore, remove the nitrogen solubility from the blood. Answer is C. Now we're going into a new topic, which is dealing with concentration of solute and solvent mixed homogeneous mixtures. As I said before, homogeneous mixture has two components at least. One is the solute, minor component, major component is the solvent. You can have a solution with many solutes. That's possibility, complex homogeneous mixture, more than more than two components. But mainly we deal with components, homogeneous mixtures with two components. Therefore, to express concentration of two components, you take part and the whole. It's called fraction. I cannot write. This is part divided by whole is fraction. That fraction multiplied by 100 is called percent. How do you get a percentage? You take the part of the component and the total everything in the solution, total divided by fraction divided by total multiplied by 100. Therefore, there are so many ways to express concentration in percent composition, as percent composition. One of the ways to use solute as a solid here, or solvent as a solid. Weight of the solute, weight of the solution. It could be a liquid or any combination, because weight could be measured in a liquid or solid or gas. How do you calculate with the weight of the water solution? That's the total. That is the part 30 divided by 70, part divided by total multiplied by 100. You get total is 30. Why total is 70? You get 30%. Remember, that's the calculation we do in all cases. Part divided by total multiplied by 100. If you have a volume of the two components are known, for example, in this 40 milliliters of ethanol are mixed, dissolved in water. The water is 60 here. Now, why 60? Total is 100. Therefore, 40 plus 60 become 100. So when you do that, P is 40, total is 100 multiplied by percent. That's how you get volume by volume. Concentration either W by W or volume by volume or any other combination. It could be weight by volume, or it could be other combination missing is. Normally we don't use that much volume and the weight of the solvent because it assumes solid solution. We don't deal with solid solutions. These are the main three concentration units that we use to express relative amounts of solute and liquid solvent in the homogeneous mixture. Now we also use parts per concentration in parts per million and parts per billion. The parts per billion and parts per million are related to percentage. Fraction, which is P divided by total, multiplied by 100 is percentage. Multiplied by 10 to the 6 is ppm. 10 to the 9 is ppb, parts per billion. Billion is a 10 to the 9. Therefore, when you using these concentration, ppms are when solute, the minor component in the homogeneous mixture is very small, is minute amount. We use either ppm or ppb, depending on the concentration. Lowest concentrations are expressed by ppb, parts per billion. So let's look at that. Very dilute solution, that means solute components very small. The parts per million or parts per billion use. You can use this to fraction what we talked about here in the previous slide. 3 fractions. Volume by volume, volume by weight by weight, volume, weight by volume, volume by volume. This could be multiplied by 100 to get the percentage. If these fractions are multiplied by 10 to the 6, you get ppm. 10 to the 9, you get ppb. For example, this is a typical example. ppms are normally, this is the weight by weight of lead ions, 1 milligram per 1 kilogram. That's called a ppm. Normally ppm are expressed in 1 millimeter per kilogram of solvent. How do I get that? 1 milligram is 1 kilogram is, this is the solute, 1 milligram. In a 1 kilogram of water, there's kilograms is 1,000 times. If you convert kilogram to milligram, you have million milligrams in 1 kilogram. Therefore, when you do that, this turned out to be 1 ppm, 1 milligram. Fraction is multiplied by 10 to the 6, become 1 ppm. Parts per billion is the similar. It's 1 microgram in 1 kilogram. That's the lowest concentrations possible for compounds which are present in the environment in small amount, yet cause a lot of problems in the health of children and humans. Pollutant is a component present in water or atmosphere, measured in parts per billion, parts per million. In most cases, some toxic substances in parts per billion can affect the health. Parts per billion is 1 microgram in 1 kilogram of water. My parts per million is 1 milligram per 1 kilogram of water. One of the other units that we most commonly use in chemistry is moles per liter concentration. Moles per liter concentration is called molarity. We talked about this in one of the previous slides. Let's talk about it more. Molarity is a concentration unit where you use fraction is the moles, part is the mole, total is the solution, moles per 1 liter. It is N divided by volume, number of moles divided by volume in liters, moles, liters. Now we are expressing the fraction as moles divided by liters. Most of the solution have certain molarity. Higher the concentration in 1 liter, higher the molarity. Number of moles are higher. How do you prepare 2 liters of? Let's look at how you prepare 0.15 molar solution, 2 liters of it. Now you don't know where the number of moles are. So how do you get moles? Find the number of moles of required. Molarity is defined as this, 2 liters here. If the molarity is 1.5, that means 1.5 moles are in 1 liter. Then liters converted, that's a factor label method that I'm using here to get the number of moles. Molarity multiplied by liters, you get the number of moles. So moles need to be converted to grams. Therefore, moles multiplied by formula weight of the sodium hydroxide. How you convert 0.30 sodium hydroxide moles of sodium hydroxide. We already gone over this. Moles divided by, multiplied by formula weight. You get back that's 1200 grams. 12.0 grams of sodium hydroxide. How do you prepare this solution? You take 12 grams of sodium hydroxide, dissolve that in water, 2 liters of water. You get 2 liters of that solution. So there are volumetric flasks. with calibrated for 2 liters. You add 12 grams of sodium hydroxide and fill it up to the 2-liter mark and shake it. You get the solution. That's how you prepare a solution with any molarity. That's what I was saying. Let's do a problem. The concentration of sodium chloride in the blood serum is approximately 0.14 molar. M is smaller. What is the volume of serum that contains 2 grams of sodium chloride? How you solve this? This means that many moles are in 1 liter. This means there are 2 grams of sodium chloride. So molarity of the serum solution is given. Molarity of the sodium chloride is given. Then what volume of serum has? So you have to convert this to moles of sodium chloride. That's what we did. Moles divided by formula weight. That's the inverse of a fraction is a division. This is divided by formula weight. You get that. So 1 liter of solution has that many moles. So how many moles are in 200? Now this has to be converted to a liter. What volume? That's asking volume. Therefore, this could be converted to 0.034 could be converted to milliliters. First, you get the liters, then multiplying by 1,000, you get 250, 240. This is moles times formula weight. I'm sorry, this is mole times molarity divided by molarity. This is molarity. That's the inverse molarity. You get, so the serum volume of 240 milliliters has 2 grams of sodium chloride. So saline solutions are used to give people suffering from dehydration and other conditions to supplement sodium chloride in the bloodstream. Now let's do some problems with these conversion factors. Concentration. We gone over this. That's the last one we did. Which of the following describe the concentration of the solution? Which of the following terms? These are volume, volume by volume, or volume by weight. These are molarities, one of them, moles per liter. Percent concentration is any of these, volume by volume. Parts per million is small amounts, therefore answer is D. "500 milliliter of salt water is prepared by dissolving salt water. What is the volume by weight by volume for the solution?" So this is part, that's the sodium chloride. That's the weight. This is the volume. So weight by volume is S. The total volume is weight by volume. Weight is 20. Volume is 500 multiplied by 100. So I did the calculation. 20 multiplied by, that's the same, 4%. The answer is C. It's pretty easy once you figure out what is parts, what is total in either weight or volume. This question, 3% weight by weight, how much salt is there in the sample. Now the percentage is given. So you can calculate, if you know the solution is 3%, $250 is the total, X is the question, you solve for X. The salt divided by is equal to 3%. So you solve for X, unknown salt, you get 7.5. All right. So it's basically working out the equation. You get the answer D. There are So many problems we are going over. What is the mass of the soul? That the total is this. The part of question. That's a weight percent. So therefore, you sold for 1.5 is the total. Sold. That's a 400. 400 is total weight. Therefore, you get sold in this problem. 6. Do you guys have any questions?
No, sir.
All right. I'm not trying to make it more difficult than it is. Just find the fraction on the weight by weight or volume by weight or moles by volume for molarities. You can calculate the concentration. Saline solution of sodium chloride in water used to deliver intravenous drugs. That's the concentration of what mass 500 milliliter solution. We in a way did that. So this is given. This is the part of sodium chloride which we this year is the question. V is given 500. You plug in the 500 here. I worked out the calculation. Sodium chloride grams divided by 500. You get 4.5. That's the C. Label on 750 milliliter bottle of oil states that alcohol content is 12%. What volume of alcohol is present in the bottle? Alcohol is this one part. Total is 750. That's volume by volume. 750 is the total. Therefore, you solve for alcohol volume right here. You rearrange the equation. You get this. Then you calculate the value, 90. That's how you get B. A 750 milliliter bottle of vodka is level 62. Do you understand? When you go to a liquor store, normally, let's take 80 proof alcohol. 80 proof means 40% volume by volume. Volume by percent, volume by volume multiplied by 2 is called a proof. In a way, liquor store try to give a large number for the alcohol. 60 proof is 30% alcohol. That's 30%. Half of that proof is half of that alcohol amount is the 30%. Now 30% is used here. That's the 30% volume by volume. That's the alcohol we need to get, the milliliters of alcohol. 750 is the total. So when you do the calculation, you get 225, this one. All these questions are looking for concentration unit and finding out the unknown from the problem. Bottle of vodka is labeled 60% proof. What is the alcohol content in? Can you answer that question? 60 proof means half of that is volume by volume percentage. That's half of 60 is 30. That's a direct question. Which of the following is definition of molarity? We already looked at molarity. Molarity is moles of liter solute divided by moles of volume of solution. Moles of solute, liter of solution. That's the definition of molarity. Let's do another problem. Volume by volume salt solution prepared by, that's the P part. This is the this is the 75 plus this. That's the solvent. Therefore, you have to add these two up to get the total. What is it? That means 7.5 divided by 7.5 plus 242.5 multiplied by 100. That's what I said. Is 3%. D is the correct answer. Glycine. Glycine is amino acid that the solution, water solution of glycine, what is the has mass of 250. This is 100. Therefore, you have to calculate 2.5 is glycine divided by 250. That's the total volume is 250. So glycine is calculated here, 6.25. I want you to go over these concentration units carefully. It's in the slides notes. I am going to continue this from here. next class period. All right? You guys okay with it? Are you guys there?
Yes.
We'll meet on Monday. Okay?
Okay.
I will talk to you Monday. Take care.
Okay.
Bye.
Bye.